This is our second lecture on probability. In this lecture, we are going to study what is probability, different type of probability definitions or approaches, and some problems related to probability, or how to evaluate or find out the probability of an event. So, what is probability? Probability defines a measure of the likelihood or the characteristics that an event will occur. That is, probability provides mathematical model for a random phenomena and experiments. Now consider a random experiment and let E be an event in its sample space S. So E is a subset of S. Let the experiment be repeated n time and let the event E happens out F out of n repetition. Then F is called the frequency of E in n repetitions of the experiment, and the ratio f by n is called the frequency ratio or relative frequency of the event. The purpose of the probability theory is to describe and predict such relative frequencies, actually on averages, in terms of probability of events. So now, how much approaches are there for the probability theory? There are three type of approaches for the probability theory. The first one is called the classical approach, then the next one is the relative frequency approach, and last one is axiomatic approach. So we will discuss each of them one by one in the coming sessions. So the first one, we call it classical or mathematical or priori probability. So consider a random experiment which is repeated n times, actually exclusively mutually exclusive and equally likely outcomes, uh, out of which F is favorable to a occurrence of the event E. Then the probability of occurrence of E is given by the number of favorable cases to the event divided by total number of cases, so equal to F by N. So consider then a experiment of tossing a head, tossing a coin, and the outcomes are H and T too. So the let H be our favorable event, then the probability equal to number of favorable cases divided by total number of cases, so it is 1 by 2. Here are some other examples, which gives how to evaluate the probability. So, what are the advantages of this classical definition of probability? So, the main advantages is it is simple and easy to understand by even a layman. In the case where this definition is applicable, the determination of probability is very easy. To determine the probability of an event, we require only the number of points in the sample space and the number of points in the events. The probability of an event is obtained accurately and not as a limit, which will be the case in the frequency definition, which will be coming session. The field of application of this definition is very wide. Okay, the next is the limitations or disadvantages. This is not possible to apply when there are infinitely many outcomes in the sample space. So when n become very large, it is infeasible to evaluate the probability. So nobody know whether the events are equally likely. So we cannot have a hard measurement to measure whether the events that happens are equally likely or mutually exclusive or exhaustive. Okay, of course we can measure it mutually exclusive or mutually exclusive, but we cannot have any method to evaluate whether the events are equally likely or not. This is the main difficulty or limitation. The field of find very finite applications. So most probably in the case of discrete random variables, and it may not be applicable in most of the continuous random variable cases. So some complicated calculation may be involved in some cases to find the number of points in the sample space and in the event. So these are the disadvantages. The next one is the relative frequency approaches. So what the main problem is that this we will have give sometimes a misleading information. For example, consider an experiment. Consider an experiment or an example in which a electrician fitted two fans, and it happens that whatever he fitted first fan is failed to work and the second fan works. So the probability of the fan that is works will be fitted by that electrician will be 1 by 2. But when actually it is because of his first consideration that he was fitting it first time, so that is what it happens like that. Whenever he goes on fitting the fan, it becomes reduced by next he fit the 10 fans, then it become 1 by 12, and so it approaches to a somewhat zero probability. This is the main limitations that we can find in the earlier definition of, or the classical definition of the probability. So in order to overcome this, always define the statistical or empirical definition based on the relative frequency. So its definition is as follows: if the trial be repeated a greater number of times under essentially the same condition, the limit of the ratio of the number of times that an event happens to the total number of trials as the number of trials increases indefinitely is called the probability of that event. So it's so simple. Whatever we wanted to do is we goes on repeat the experiment as many as possible times, and we find the ratio f by n. On when n become very large or somewhat very large, then the ratio f by n approaches to a constant number. This constant number is called the probability, and is denoted by p of e. So in mathematically we can put it as p of e equal to limit n tends to infinity f by n. So the advantages of this definition. So it provides a practical method for estimating the probability of an event. It is easily understood even by a layman. No elaborate calculation is necessary to determine the probability of event, except that we have to go for the limit, or we can able to find out that large n for which this ratio approaches to a constant. So it gives a clear idea about the concept of probability. The probability of event can be determined without making assumption like equally likely. Again, this definition increases the domain of application of probability. Therefore, in various branches of modern sciences and social science, we can apply it. Disadvantages or limitation. Only an estimate of the probability of event can be evaluated by this method. Second one, the event when it is difficult in some situation to evaluate the limit or to find out the large n at which the ratio f by n converges. If the experiment is hypothetical or imaginary, this method cannot be applicable. So the last one and the third one is called the axiomatic probability. It will overcome all the limitations of the both the probability approaches that we are defined earlier. So the axiomatic probability consider an experiment and the sample space, and of course the sigma field that we defined in the earlier class. So we can define axiomatic probability as: consider an experiment with a sample space S, and for any event E, we can associated real number P of E which satisfies the first axiom P of E greater than or equal to 0, the second axiom P of S equal to 1, and if E1, E2, etc. are mutually exclusive and or disjoint events, that is EI intersection EJ equal to 5, whenever I not equal to J, we have probability of E1 union, E2 union, etc. is the sum of probabilities of P of E1 plus P of E2 plus etc. So these are the axiom associated with the axiomatic definition of probability. So now we go for the theorems of probability based on this axiom. So for any event E, P of E lies between 0 and 1. So the proof is very simple because we know that let A be an event and which occurs f times and n be the total number of events, then f can take the value between 0 and n. So the minimum value that f can take is 0 and the maximum value f can take is n. So we have 0 less than or equal to f less than or equal to n, and if we divide throughout with n, we get 0 less than or equal to f by n less than or equal to 1. And now by taking the limit, we have 0 less than limit n tends to infinity f by n less than or equal to 1. Since but limit n tends to infinity f by n is p of a, which gives the result. So 0 less than or equal to p of e less than or equal to 1. So the theorem is proved. Second theorem, we have P of S equal to 1. Again, by the frequency definition, the P of S is limit n tends to infinity f by n, where f is the number of times the event S occurred out of the n repetition. Since S is the sample price, in always every time any one of the elements of S happens, so S occurs in every time. That is, if we repeated the experiment n times, then S occurs n times. So the P of S can be written as P of S equal to limited to infinity n by n, that is equal to 1. So the theorem is proved. Now the third theorem is that P of E plus P of E complement equal to 1, or P of E equal to 1 minus P of E complement. So let E be the events happens in F out of n repetition, F times out of n repetitions, then V of E complement happens in n minus F times. So probability of E complement equal to limit n tends to infinity n minus F by n by the definition of probability, which is from which we can get is as 1 minus limit n tends to infinity f by n. So this is 1 minus p of e. The third theorem is thus proved. Now the fourth one, for any null event phi, p of 5 equal to 0. By theorem 1, we can have 1 p of 5 equal to 1 minus p of 5 complement, which is 1 minus p of s, and by theorem 2 we have p of s equal to 1, so substituting it we get p of 5 equal to 0. Okay. Next one is the additional theorem. So for any event a and b, p of a union b equal to p of a plus p of b minus p of a intersection b. So let A and B be two events in a random experiment which are disjoint. Let the experiment be repeated n time. Let A occurs f times, B occurs g times, and both A and B occurs h times. So the total number of times A or B occurs is f plus g minus h. So P of A union B equal to limit n tends to infinity total number of times divided by n, which is f plus g minus h by n. So fractioning the limit into the addition and minus, we get limit n tends to infinity f by n plus limit n tends to infinity g by n minus limit n tends to h by n. That is p of a union b equal to p of a plus p of b minus p of a intersection b. Okay. So here is an example how it happens A1 union B, and you can do it yourself. So next one, if A and B are mutually exclusive or disjoint, that is if A intersection B equal to 5 and then P of A intersection B equal to P of I equal to 0. So in this case P of A union B is P of A plus P of B. Addition theorem for three variables, we can extend it to any variables. Now I extended it here to the three variables. So P of A union B union C is P of A plus P of B plus P of C minus P of AB minus P of BC minus P of AC plus P of ABC. If B is a subset of A, then we have P of B is less than P of A. Now next one is the conditional probability. The conditional probability of an event A, given that an event B of the same sample phase has happened, is that, and is denoted by P of A given B. So this occurs when uh, the first event happens and only after the second one happens. So if we can think about A only if B should be happened. So the definition we can define it as let P of A given B is P of A intersection B divided by P of B, provided P of B not equal to 0. Similarly, P of B given A is defined as P of A intersection B by P of A, provided P of A not equal to 0. Okay, next one is the independence of two events. Two events A and B are said to be independent if P of A given B equal to P of A or P of B given A equal to P of B, or another condition P of A intersection B equal to P of A into P of B. So if A and B are independent, we have the following results. If P of A and B are independent, then P of A given B equal to P of A and P of B given A equal to P of B, and P of A union B equal to P of A plus P of B minus P of A into P of B. Okay, now the last theorem, that is the multiplication theorem. For any two even A and B, P of A intersection B equal to P of A into P of B given A, provided P of A not equal to 0, or P of A intersection B equal to P of B into P of A given B, again P of B not equal to 0. So the proof is directly followed from the definition of the theorem. So P of B given A equal to P of A intersection B by P of A, which is the definition of conditional probability. If you take the P of A in the right left hand side, we get P of A intersection B equal to P of A into P of B given. So this is the an introduction or theorems and definitions of probability. So then in the next class we discuss the random variables. Thank you.